We're still in Chapter 6, the periodic table chapter, and we are moving along to test hint number 23. We've been talking about electron configurations, how that relates to the location of an element on the periodic table, and thus the properties of the element. And remember, in the last chapter, we learned how to write those configurations. We hope that you're seeing now in this chapter why learning that skill was so important, because that determines how we relate elements on the periodic table and even organize them in the first place. And in the next chapter, we're still going to be talking about electron configurations, because we're going to then go into ionic and eventually covalent bonding, where we're really going to look at the activity of those elements based on what their valence electrons are doing. Okay?
All right. So we were jumping into number 23, the number of valence electrons in a given element. And in that last test hint, in the last segment, you were saying you look at the groups, the columns that the elements are in. And for example, you know, the S block and then P block, you look over here, if you are a halogen, the end of your electron configuration is P5.
Right.
But you have to remember that you have these S electrons that are part of that same energy level.
Right.
So for example, fluorine, truly the end of its electron configuration is 2s2, 2p5 for a grand total of 7 electrons.
In the outer energy level.
Right.
And maybe we should jot that down, because we keep using the term valence electrons or valence shell, and we're also referring to them as the outermost electrons, or the electrons in the outermost energy level.
Right.
That all means the same thing, and you should just, not be surprised if you see us interchanging this terminology when you get to a test question.
Knowing more words is good.
Good. Alrighty, test hit number 24. What valence electrons are? Valence electrons are the ones, how many times do we have to say it, in the outermost energy level. So this question should be a slam dunk. I personally think valence electrons are the most important thing in chemistry, and then the mole concept, because valence electrons are what lets these elements do what they do.
So speaking of valence electrons, we get into periodic properties, properties of the chemical elements, and here on test hit number 25, it says electronegativity. And
that's a big word.
It is. It's an awesome word. It's an automatic win in Scrabble.
Yeah.
If you can hook that up in Scrabble, your opponents will cry and quit.
Right, right.
Electronegativity is a measure of a nucleus's pull on its electrons.
The pulling power.
The pulling power. Some atoms really want more electrons because they're tiny and the nucleus is exerting a lot of force on any electron that might come zipping past.
It doesn't have to reach out to too many energy levels to hug those electrons in.
So small atoms,
right?
pretty big nuclei. We're looking at these guys over here on the end of the periodic table. Not the noble gases, but fluorine, the most electronegative element on the periodic table. Oxygen, chlorine. These guys have pretty big nuclei and not a lot of electrons in between
Right.
that nucleus and
the
outer ones.
So that shielding effect, which I'm sure will be coming up in a second, the shielding effect of those D electrons, maybe F electrons, the inner shell electrons, has less of an effect in a small element like fluorine. So we have a trend for electronegativity that goes that way on the periodic table. We've got increasing electronegativities to this upper right corner, but not the noble gases. And go back and look at some of the 3D graphs we've got posted on Moodle. You can see it in, it's very obvious. The elements that really want more electrons to fill out their outer shell are going to have the higher electronegativity. Okay? And 26. Now, this hint says electron affinity. So here we have another term that sounds like the one that we just went over, and it happens to have the exact same trend. Electron affinity is talking about an amount of energy. And that is energy that is released by an atom when it gets its additional valence electrons to fill up its outer shell. So it should make sense that an element like fluorine with a high electronegativity that really wants additional electrons would also have a high electron affinity, giving off a lot of energy when it gets those additional valence electrons.
Fluorine has 7 valence electrons packed in real close to the nucleus. It's really excited to get that 8th electron. It is so excited to get that 8th electron. When it finally gets the 8th electron, oh, thank God. And it releases that energy, and that number is negative.
Yeah, well, chemists do that.
Yeah, indicating that it is released. It's going away from me. So a high negative value for electron affinity is characteristic of these guys up here.
Right. Alrighty, we are on 29.
29, I believe, yeah.
Yep.
Is that 29?
Oh, no,
No,
27.
And that goes back to that shielding effect. Shielding effect is the effect that inner electrons have that decreases the attraction that the outer electrons feel from the nucleus.
Okay.
It's kind of like wearing a coat.
Right.
If you are cold and you want to snuggle with somebody, you don't want to snuggle with somebody who's wearing 25 layers of clothes, because you're not going to get any of their body heat, because those layers of clothes shield you from the heat that your snuggle buddy is
Right. Now,
giving off.
my class might remember that I stood on one side of the room and I designated them as the electrons in their rows and tables there. And then I was the nucleus trying to get their attention. And I talked about, you know, if somebody was trying to break free from this room, the atom, and then fly out the door, and I had to keep them in, which people, electrons, am I going to be able to grab the most easily and have the most attraction for? And those would be the ones closest to me, and the chairs that were closest to me. If I've got to go past all the students in the class and try to reach out to somebody that's trying to run out the door, it's going to be difficult, because all those other people are providing a shield. They're acting like a shield, providing a barrier between the influence of the nucleus and those outer electrons.